Hello, I am Juan-Juan, your system instructor, and today we're going to discuss reverse capability. In other words, how to calculate your specification limits to achieve a given capability index.
Juan, I like your jacket.
Thanks.
But before we start, can I ask you a question?
Sí,
Do you like sports?
sí, I love sports. Actually, I practice martial arts.
What kind of martial arts?
Oh, I am a master in Taekwondo.
What about basketball?
I like basketball, but I play only Juan-on-Juan.
What about golf?
Well, I get frustrated with golf
Why?
because I never get a hole in Juan. Anyhow, let's talk about reverse capability. Welcome back. Reverse capability is a technique that we use to calculate the specification limits or print tolerances when the process needs to reach a given capability index. In normal capability studies, like this one, the print specifications are already established, and what we need to evaluate is the capability indexes, such as the CPK and the PPK. For more information about this, please watch my capability videos. But what about the other way around? Let's say that you need to establish the print tolerances of a given dimension, and the company has asked you to achieve a minimum CPK of 1.67 and a minimum PPK of 1.33. What do you do? How do you establish the print tolerances in order to achieve these indexes? Let's review an example. For this example, the dimension is going to be the thickness of my head. By the way, this example is based on a real case that happened to me. Well, except the head part. Before we start our calculations, let's review where the numbers 1.67 and 1.33 for capability indexes come from. As you can see in this chart, the normal variation for the process is represented by 6 sigma, or 3 sigma on each direction. And the print tolerances are established at 5 sigma on each direction from the center of the specification or the process mean. If you divide 5 sigma over 3 sigma, you will obtain 1.67, which means that you have a safety factor of 1.67. In other words, your process needs to have a variation larger than 67% for the dimensions to go out of tolerance. In the same fashion, 1.33 is obtained by dividing 4 sigma over 3 sigma. So you have a safety factor of 1.33, and your process needs to have a variation larger than 33% for the dimensions to go out of print tolerances. 1.67 for short-term capability and 1.33 for long-term capability have become the preferred index values. Going back to our example, the first step is to establish your baseline and determine what is the current condition of your process. In reality, you only need to determine the standard deviation and the mean of the sample. Mr. G measured my head 30 times, and as you can see, the readings are between 24 and 25 millimeters. So, we establish a baseline specification between 24 and 25 millimeters. You need to do this only if you are using Minitab, but if you are calculating the mean and standard deviation in a different way, you don't need to establish the baseline tolerances.
Juan, is your head okay after being measured 30 times?
See, my head is okay. Well, I guess. Let's continue. We use Minitab 21 to get the 6-pack report as follows. We pointed to Stat, Quality Tools, Capability 6-pack, and click Normal. When the box opened, we selected Juan's head data and entered the upper and lower specifications of 24 and 25 millimeters. Click OK and open the report. As you can see, we obtain a CPK of 1.29, which is below the required 1.67, and a PPK of 1.12, which is also below the required 1.33. So we need to establish new print tolerances, and here is where the fun starts. So before we do the math, let's take a break. To calculate the upper and lower specification limits, or print tolerances, we can use either the CPK or the PPK formulas and calculate the limits in reverse, hence the name reverse capability. In other words, we are going to use basic algebra to establish a new formula. For this example, I am going to use the CPK formula, calculating the upper limit first and using the standard deviation of the sample, or standard deviation within. You can also use the PPK formula if you want, but if you do that, be sure to use the standard deviation overall. To start, we take only the one element of the formula that contains the upper specification limit, and we need to resolve the equation for it. Now, you may use algebra in a different way, but no matter what method you use, the result should be the same. Math is the only universal language, including aliens. We need first to remove the 3 sigma from the denominator, so it goes to the other side of the equation as a multiplying factor. So now, the 3 sigma is in this side. Next step, we need to move the mean to the other side of the equation, so it goes from a minus to a plus on the other side of the equation. And voila! We have established the new formula for the upper specification limit, which is the CPK value multiplied 3 times for the standard deviation plus the mean of the sample. And the next step is going to replace the values of the variables with the actual number of our baseline capability study. So, going back to the baseline study, we need to get the value for the standard deviation right here, which is 0.1198, and the value of the sample mean right here, which is 24.4643. Next, we replace the values of 1.67 for the CPK times 3 times the standard deviation of 0.1198 plus the sample mean of 24.4643, and we obtain the value for the upper limit, which is 25.064498. Putting a dimension of 25.064498 in the print as upper limit will be difficult, so I always recommend to round up for upper specification limits, so the upper tolerance could be rounded up to 25.1 millimeters. We calculate the lower tolerance in the same way, and we round it down this time since it is the lower limit, and obtain a value of 23.8 millimeters. You can do this calculation as homework and should obtain the same value. And we are done. We have calculated the new print specifications using the reverse capability method. Let's celebrate! To validate the results, let's go back to Minitab and recalculate the capability indexes using the new tolerances. We use Minitab 21 again to get the 6-pack report as follows. We pointed to Stat, Quality Tools, Capability 6-pack, and click Normal. When the box opened, we selected the Juan's head data and entered the new upper and lower specifications of 23.8 and 25.1 millimeters. Click OK and open the report. As you can see, with the new tolerances, we obtain a CPK value of 1.77, which is above the required index of 1.67, and we obtain a PPK value of 1.53, which is also above the required value of 1.33. So, our reverse capability calculation was successful, and we have established the new tolerances for the print of my head. Now, let's go to the final thoughts. And here are my final thoughts. Reverse capability is a very useful tool to calculate your print or specification limits if they are not known or need to be established. But be careful, this technique only allows you to establish the limits with the current standard deviation of your process, and if you're trying to reduce your standard deviation or variation of your process, you need to use a different tool for process improvement.
Juan, before we leave, can I ask you another question?
Sí,
Have you been watching football?
sí, I have been watching football, but I don't like Lionel Messi.
No, Juan, I meant the American football.
Oh yes, I like the American football too.
What is your favorite part of the game? The touchdowns, the field goals, or something else?
Oh no, my favorite part of the game is when they run the ball in 4th and Juan. Well, that's it for today. See you next time. And until then, take care of yourself and each other. Mimi, let's watch the birds.